Speed.
Velocity.
Acceleration.
All right, so these are 3 types of motion, or 3 types of measuring motion, I guess.
Yep.
Yeah.
Measurements.
This should be a really quick one, because actually you guys have learned speed already.
Yep.
This is actually the same exact slide from the last
Couldn't have a lot
video.
of discussions without talking about this stuff already.
So, yeah, speed is the change in distance over time by an object.
Yep.
Remember, the formula for speed is distance over time. I'm not going to spend more time on this because you should know it already.
Miles
No.
per
Although,
hour, meters per second.
a
those
quick
kind of
reminder, remember that there's a difference between average speed,
And
which
instantaneous.
which is when you take the total distance divided by the total time,
Yeah.
or there's instantaneous speed where that's you actually just look at the exact speed things going at that very
At
moment.
that exact second.
True.
Okay.
Speedometers.
Yep.
So anyway, Mr.
I'll take it.
Okay.
Take that one, velocity.
So
man.
velocity is kind of like speed.
Yep.
With a little bit of a twist. So basically, you remember speed is your change in displacement over time, so miles per hour or whatever. Velocity is the same thing, except you add in one hugely key element, and that is it has a required specific direction.
Write
So
that
instead
down,
of
guys.
yeah, big time. So velocity points you in what direction you're going in. It's not just miles per hour. It's like miles per hour north or south or east or to the right or to the left
Up the
or up or
stairs,
down or
across the top of the
backwards.
building,
Right.
or
Right. The
through
key
the
thing
lake,
is that
whatever.
it's got a direction to it. If it
Yeah.
doesn't have direction, then it's just speed. Velocity is more useful because you're not only telling how fast you're going, but you're also saying
Yeah.
where you're going and in what
Velocity is more how scientists measure
Right.
this kind of thing. Speed is more like the public thing. Velocity has to do with a bunch of stuff we're not going to get too deep into.
True.
Right.
But it is important to understand the direction forces are going in. We all know forces.
So if you're wondering, we didn't specifically put out the formula on the slide, even though it's on your note sheet. The formula is the same exact thing as speed. It's distance
Just put a
divided by
direction at
time.
the end.
And I'll know you're listening to the notes if you have that written down or not.
True.
But remember that once you
Yes.
calculate that, you need to say what direction you're going. So
and usually the direction is included with the distance. So you're going to say
Right.
like miles north, and then you divide it by the time, and that's how you get miles per hour north.
right.
Yeah.
Well, here, and let's even do this quick practice.
All right.
You're driving northwest to Madison, Wisconsin from Gurnee. It takes you 0.5 hours to drive the first 20 miles. What is your average velocity during this time? Actually, you know what? Well, wait. Why don't you calculate it real quick? Get an answer?
Hope so.
Did you get the right answer?
You just do 20 miles divided by 0.5 hours, and you get 40 miles per hour, and you went northwest.
Yep.
Right?
That was our
So-
direction.
So
North,
if you just wrote 40 miles per hour, you are wrong, because
That's
that's not a
speed.
velocity.
That's not what we asked
Right.
for. Velocity has a direction.
Right,
All right. Let's roll it.
Cool.
Now, velocities could actually be added. I'm talking too much. Go ahead.
Oh, no, I was going to say velocities, you can actually add velocities together to find the total velocity in that.
Right.
So, for example, we have our cool little Simpsons fish that right down there.
Blinky is his name.
Blinky.
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 So we got Blinky, the three-eyed mutant fish, and he's swimming in a river that is moving 3 meters per second. Let me get this straight. It's going to be to the right.
Yes.
Okay.
Mhm.
And he is swimming with the river, which means he's also going to the right, and he's doing 2 meters per second.
Right.
So, river's pushing him. He's swimming with that, the speed of, or the velocity of 2 meters per second to the right. You add those two together, it's 5 meters per second to the right.
Wow.
Right.
That's how
So-
fast he is totally.
So you just add them together.
Yeah, if they're going together.
Like kind of a real life application of this actually that I recently experienced. I was on a plane and we were flying with the tailwind, right? So
Yeah.
the pilot even said the plane is going like 600 miles per hour, but the tailwind is going 60 miles per hour. And by the way, he did say east because we were going east. So
Yeah.
he's doing good velocity.
Yep.
But then he even said, so that means we're going, I forgot what numbers I said, but so he added those two numbers
660.
together and he said that's our total.
Like 660,
Awesome.
yeah. Because and that's how like pirates, like if you dig pirates, that's how they're like, oh, you go with the wind, so the ship is going a certain way, and if they're rowing, you've got like the oarsmen, and they can row, and the ship gets pushed, and there's all kinds of
True.
stuff.
Right.
You can
Now,
add these together.
On the flip side, this runner is running 3 meters per second, but why are they staying still?
Probably because the treadmill is going in the opposite direction at 3 meters per second, which is a good thing because that means they cancel each other out for a total velocity of
Goose
0.
Yep.
Which is good because if you're running on a treadmill, the last thing you want is to go faster than the treadmill because you're going to face plant.
yeah, you're gonna chest plant on that thing,
Yeah.
or if you go too slow, you go
you're gonna
flying
shooting off the back.
Fail videos for the win.
Yep.
Right.
Now the final concept is acceleration. Acceleration is a measurement of the change in velocity over time. So this is any change, by the way. Even if you slow down,
Right.
you are
Yeah,
technically
it's negative
accelerating.
acceleration.
It's just going to be a negative number.
Yeah,
Correct.
Negative acceleration. It's a change. So acceleration is the thing, your little delta. This is the change.
Right. So the way you calculate it is you figure out the final velocity, the initial velocity, and then calculate how much time it took you to actually do the movement.
Right.
Okay. So this formula is a little more complicated in the way it's written because sometimes you have to look at a group of data and say, oh, at 0.1 minute they changed speed. So that's where you would actually use an initial time. Most of the time in this class, we're just going to say, okay, it took them 5 seconds to go from this speed to this speed.
Right.
So
Yeah.
that's why I wrote that this is usually 0.
Right. It makes
seconds.
things a little.
Yeah,
Yeah.
and we're going to work with this in class. The thing to keep in mind is if you're talking acceleration, it's like over a distance, over a time. So you're going to say, I started here, I ended here, I started this time, I ended this time.
Right.
And we're going to use that information. It's just, it took me this long to go from here to here.
And there's a way to do quick checks. Like if you know that your velocity is going increasing, you're probably accelerating positively.
Yeah.
If your
Going
velocity
faster.
is going down, then your acceleration is probably becoming
Putting the
negative.
brakes on, running
So
into the
just kind of
wind,
think of it that way.
stuff
Like
that.
if your final velocity is bigger than your initial velocity, your acceleration better end up being positive.
Yeah.
So here's a quick practice problem, and I actually put the formula here. We're going to plug in the numbers together here.
Right.
So
Yeah.
car is traveling 5 meters per second, and then the driver accelerates for 5 seconds and ends up at a speed of 20 meters per second. What is the acceleration of the car? So first of
Right.
all, what is the final velocity there?
Final velocity
20
is
meters per
20
second.
meters per
20 meters per second, okay? Because that's what they were at the end.
Yeah,
right?
that's where we ended up.
What is the initial velocity?
5.
5 meters per second.
Yep.
Okay?
Started.
So we got those numbers plugged in. Now we got to figure out our time. Now, how long did it end up taking?
5 seconds.
5
5
seconds.
seconds.
Okay, and this is one of those cases where we just started measuring at the beginning of the problem.
Right.
So
Yeah.
it's going to end up, we're going to plug in 0 seconds here. So you got 20 minus 5, which is 15.
15.
And then 5 minus 0 is 5. So you have 15 divided by
Divided by
5, and that gives you 3 meters per second
second.
squared.
Yeah.
Now, I've seen people in class writing meters per second for acceleration already, which we haven't really gone in depth about acceleration, so I've been forgiving. But acceleration is not saying your speed; it's saying how much your speed is changing
So
in a
that's
certain
the
time frame.
Per second, or per second
Right.
squared. Guys, remember gravity, the gravity constant?
Mm-hmm.
9.8 meters per second squared on Earth. That's an
Right.
acceleration due to gravity. Here's
And-
acceleration coming back. Meters
And what
per
this
second
means
squared.
is that every second of time that goes by, that car is going an additional 3 meters per second faster.
Yes,
Right.
it's increasing in this case, or if it's negative, it would be decreasing at the same rate.
Right.
All right, well, do your checkpoint.
Do your checkpoints, guys. Do it. Knock them out. Kick butt.